Hello again. Kevin Call, PM Head of Cloud Management Solutions here at Supermicro, continuing our podcast on building and monitoring an AI factory. In the previous video, we focused on an in-rack solution, and based on that, we were able to collect sensor data. We provided lifecycle management. We talked about enforcement policy, and we showed you how this particular CDU is part of an in-rack solution that provides essentially the nucleus or the heart of an entire liquid cooled solution in a rack. So we're moving now into today, we're going to talk about what referred to as InRow solutions. In previous videos, we talked about the rear door exchanger and also the InRow CDU as options or valuable options for InRow solutions. Today, we're going to focus on the Sidecar, which is a very interesting type of data center asset that comes into your data center to be able to support liquid cooled data centers. And this device essentially is relatively new to Supermicro as a new offering. And so we have been building a sidecar here as prototype for a while, and now we're releasing this to the industry as a viable solution for some of the folks that maybe are transitioning right from what were referred to, air cooled into liquid cooled, and they want to do it in phases, right? So this would be something perhaps would be a more of a brownfield type of solution opposed to building a data center from scratch and allocating the piping to be able to support a liquid cooled data center. So very interesting solution here for our customers that can sort of gingerly move into more of a liquid cooled solution. So one of the other things I wanted to talk about is that this is a small lab where we expose two sidecars in our configuration here, and because of this being a relatively new product, we are just getting started in really providing rich metadata for this particular device to monitor and manage and learn against. So we've brought in what we call phase one of our sensor data collection. As we continue to move to subsequent releases, we will bring in additional features that we will expose for this particular data center asset. And this is all part of our DCBBS initiatives that our founder and CEO has talked about in driving and building a data center and being able to support neo clouds. So let's get into it here. So all of our users come into these menu option or this main dashboard, which is read only. And typically an operator would see this information. We talked about various quadrants that exist here. I'm not going to get into that detail today because those are provided and exposed in additional vignettes and playlists that are part of our SCC YouTube channel. But let's dig into really the coolant infrastructure piece of this, and let's pull up the menu option here, Sidecar. And you could see here in the list here, we provide sidecar information or a list of sidecars that would be monitored and managed within your liquid cooled data center. And so we would see this list as probably a list that's large, depending on the size and scaling of your liquid cooled data center or where you're transitioning from air cooled to liquid cooled. And so we would see these devices basically showing up in this particular list. And then on the left-hand side here, we break it down into a tree architecture to provide you a understanding of how these particular sidecars are associated with an InRow solution. And we'll get into the detail here to show you here how you observe which particular racks are associated with this particular sidecar. You'll also notice here in the left here, as my mouse hovers over here, is the icon to represent what a sidecar is and what it represents. And so each of our particular icons that are present within SEC signify or represent the widget or device or the various different health roll-ups associated with a compute device. Switches have different types of icons. So we've maintained an icon list to represent and show you the differences between the different data center assets in your data center. All right, so let's look at the sidecar list in a little bit more detail here. We see here the name of the sidecar. We see the ability for you to log in to the BMC of that sidecar by clicking on it and then logging in physically into that device through the BMC. So we provide that capability and functionality for you to do so. And then you can see here that this is actually set to the default rack server name. So it's not part of a pod, right? But it's part of a rack, right? And we talked about that in pod view here, where each of these racks could be grouped together based on a common workload, right? But in this particular use case, or what we see here, is it's only defined in the default pod and associated with a rack in that default location. We see the row location, and each of these particular InRow solutions have maybe a series of particular racks that need to be associated with a particular InRow solution, whether it be a rear door exchanger, whether it be an InRow CDU, or whether it be a sidecar. And you can see here we have the health is in good standing, we have the state is enabled, it's a managed connection state here, and we have the SKU name here as LCS SCDU, and then we have the serial number appropriately with that sidecar, and then the firmware version, and then the related rack count. So in this particular example, we just have the sidecar widget or data center asset. There's no related racks associated with it. If there were, they would show up as a value north of the zero value, such as maybe perhaps 1 or 2 itself. So let's click on the sidecar itself, and let's dig deeper and see what we can discover of what sensor data we can pull from this sidecar. So we see the front view in the rear view. In the front view, when you physically go to the sidecar, there is a panel here that provides you with information such as configuring the IP address and doing additional types of settings you can set associated with the sidecar. And they're provided in this panel display that's in front of the sidecar. And then you also have the rear view, which nothing too interesting there, showing you what the rear view looks like. On the right-hand side here, we provide detail of physical asset information at a very high level. We show you the health, we show you the version, serial number information here, and then also the product SKU and the type of model we have. And then, of course, you can click here on the blue to directly connect into the BMC of that sidecar, or up here through what we call the sidecar website. On the top of the carousel view, we see energy and power consumption. That's a typo here. We'll have to make a change here to make sure it shows power consumption or power consumed as a past tense here. So a little bit of a typo there with that one. The same kind of experience clicking on the actual carousel view will stop the information from scrolling. And so this sensor value is a little different, and it has to do with what we refer to as turbidity, right? And you say, well, what the heck is turbidity, right? I had to actually look it up, quite honestly, to understand what that what that word was, because I never heard of it before. And it really has to do with how clear the substance or liquid is that's passing through this particular sidecar. And that becomes very, very important. The turbidity is that as it continues to move north of basically, say, a value there, the value could be, say, point, and could be closer to zero as it moves south to zero, the actual substance becomes clearer. As you continue to move north of the value, such as zero, then the substance becomes cloudy. And when it becomes cloudy, that actually enters into particles or contamination or contaminants inside there that could result in essentially a problem in regards to cooling your particular racks, excuse me, that are associated with this particular sidecar. And specifically, that has to do with a filter that needs to be changed. So we will alert on this to indicate here when the turbidity becomes a certain threshold value, then we will basically flag it that that particular filter needs to be replaced so that we can maintain consistency and stable, that whole substance and liquid substance is going to be a lot clearer so that your particular environment, as far as racks are concerned and your workloads that are running on those GPUs, maintain optimization. So that's a little bit on the word of turbidity and give you a little bit of perspective of that value, which is a very important value, quite honestly, that we are collecting against. So let's look deeper into the navigation view, which is pulling up information about this sidecar. And you can see here on the left-hand side, it opens up additional menu options on the left of our control plane here. The sidecar rack mapping indicates the racks that are associated with this sidecar. We have no records because there's no particular racks that are associated with it. It's just an individual device that we're monitoring in our particular mini liquid cooled lab here and being able to collect relatively stable sensor data. All right, so let's click on the sensor rating information here. And again, we have the ability to get data from that particular sensor data that we provide in a window on the or an icon on the top right here with the actual last time that we were able to get sensor data information based on an uptime that we provide here as a timestamp. You'll see here also that it's in automatic mode. There are different types of modes that we provide within the sidecar. So right now we're defaulted to automatic. As I mentioned, additional sensor data and lifecycle management will come into subsequent releases and new features that we're going to build into this particular product. On the bottom here, we actually group them into what we call sensor list data. And you can see here that we provide current value readings for each of the various different sensor data that we're collecting. Things like value percentages of fan speed, energy in kilowatt measurements, and then filter delta, pressure, KPAs, so on and so forth. So if we continue down the list here, it's pretty much rich in data that we're actually pulling from this particular device. And of course, we're going to build in leak detection as well and set our enforcement policy appropriately if there is ever a leak that's detected so that we can actually use the same methodology and understanding that we did in our in-rack CDU. So potentially a leak is a problem. We hope you never have a leak in your liquid cooled data center, but we need to have a monitoring and management platform to be able to protect your assets that are basically in a data center. So that concludes today's presentation on pulling very basic but important sensor data for our phase one development cycle. As I mentioned in previous videos, the rear door exchanger in Sidecar will be released in the 3.11 code stream, which is in system lab validation right now and will be released in approximately 2 weeks. So that concludes today's video. Thanks for joining today. I bid you a great day here, and we'll see you next time.